according to the recent trends that I'm aware of, it's still very well on the rise. And I don't really see any contenders on the horizon. And that could probably be because there is something for everyone. So there is the argument that it's really easy to get into for the beginners, but there's also ways to make it really efficient if you need to by writing some parts of it in Python, which then under the hood uses C and is much more performant.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the Geospatial community. My guest on the show today is Anita Graser, and she is an absolute legend in terms of Python and Geospatial. She's been working in the open source geospatial world for a lot of years, and she has an incredible amount of knowledge. So today on the show, we're going to be talking about how we might get started with Python, why Python is a great language for geospatial, and she's going to be sharing a few of the resources that she has available on her website and her insights into the language. Should we be learning this? Is there a future in Python and Geospatial? Just a quick message from me. Sometimes as a podcaster, it's pretty hard to know what people actually want to hear about. So you could do me a huge personal favor. You could get in touch with me via our email. If you go to mapscaping.com/podcast, and you'll see a few options there. Sign up for an email and use that as a way of contacting me. Let me know what you like, what you don't like, what I can do better. I would really appreciate it. You're also more than welcome to reach out on social media, but I would love to hear from you. It would really help me shape the direction of this podcast. Okay, that's it from me. Let's get into the interview. Hi, Anita. Welcome to the podcast. I'm so pleased that we could make this work. We've had a few attempts at this, and it hasn't really worked out until now. So I'm really looking forward to this conversation. This is something I've been looking forward to for quite some time now. So you have done an incredible amount of work in the open source geospatial world. You've done a whole bunch with QGIS and obviously a lot with Python, and it's Python that we're going to be talking about today. But I think before we dive into Python and start talking about the work that you're doing there, perhaps you could just give us a few more details about your background, how you got involved in open source geospatial.
Sure, and thanks for having me on the podcast, Daniel. My background is in GIS, so I started working with QGIS around 2008. It's been a while, and I pretty much from the beginning did work with Python and the Python integration in QGIS because I had all these data analysis tasks to solve, and it seemed like the perfect tool to do that, to automate some mapping and to look at the data in different fashions, not just on the command line or in graphs, but also in maps. So that has been 12 years since I started with QGIS. Then in 2013, I joined the QGIS PSC, and I've been on it ever since.
So I think before we really get into talking about Python, I think we should sort of explore the idea of why Python and geospatial. Why are those two things a good match? When people ask, what language should I learn in terms of spatial, Python is almost certainly the first language that people suggest. What is it about Python and geospatial?
Yeah, that's an excellent question. 10 years ago, I think it wasn't so clear that Python would be the language that we would all be learning, because back then there was a lot of contenders floating around. I think it was pretty much 12 or 13 years ago when ArcPy came out and PyQGIS came out. That's when it really started to get clearer that Python, because it's versatile, it's relatively easy to learn, might be the way forward, and that proved to be true in the end. What I found very convincing about Python right from the start when I learned how to use it is that it's really good at data manipulation. And as GIS people, we have to do a lot of data manipulation. If we're honest, that's what we do most of the time, right? We get some data set and then we try to wrangle it until it's finally hopefully usable. And Python does that really well, either from files or from databases. So what really blew my mind was how simple it also was to interface with Postgres, PostGIS in Python as well. from there, you can really take it so many different ways. You can do automation of workflows with scripts. If you're coming from a model builder side, you can usually export those models as Python scripts, or you can write them from scratch, however, whichever workflow you prefer. And of course, we have the huge opportunity of building extensions for desktop GIS and server GIS using Python with plugins in open source as well as in proprietary systems. So I think there's many reasons why Python is now the universal language almost in GIS.
Yeah, I definitely think that with the amount of integrations there are to Python and the way it can really act like that glue that can hold so many things together, and of course the flexibility of it as well. If you know Python, if you understand how to use it in a geospatial data manipulation situation, you're not restricted to just pushing buttons. You can make it up as you go along. And I think you mentioned the idea of those reproducible workflows as well. So I don't know if I completely agree with the idea that code is self-documenting, but I like the idea that when you do something in Python, if you script it, you make that workflow that you can easily, manipulate some of those parameters, run it again and get a different answer and sort of refine things, and also hand it over to someone else and say, here, I did this. This is exactly the way I did it.
Most of the code, unfortunately, is not self-documenting. Really good code might be self-documenting, but it's hard to get there. But of course, there's an advantage in writing code because you cannot forget to document a certain parameter. It will be in there to look it up later on if you want to find out what exactly have I been doing here. The problem often is you might not know why you were doing those things if you don't have any additional documentation besides the code. However, if you have a report and code, then you're usually pretty good already, and that's far above the average situation that we have when we inherit someone's data.
So I'd just like to move on now and talk about how we might get started. So I realize we're starting right at the start here. We talked about why Python might be a really good choice, all the advantages that come with knowing Python. So if we take the next step, and for me that would be, so how do we get started? Do you think, for example, it would be a good idea to learn Python as a language for itself and then add the spatial component to it? Or if you were learning from scratch today, would you jump into the spatial side first?
I think it depends a bit on the individual's background. So if you already know some programming language, then it's probably safe to just jump into the geospatial and figure out the Python specifics along the way, because it's not a hard language to learn. I already mentioned, I think it's very easy to get into. Maybe if you don't have any background in programming, it's worthwhile to look at the basic concepts, like what are loops, what are functions, what are classes, before you start doing the geospatial specifics. However, I found that people need some motivation, and particularly GIS people, a lot of them, they want to see something on a map real quick because that keeps up motivation. And that's why I started to do, even for people without programming background, to have those first initial steps already be something that is related to geospatial. And that's the main reason why I started writing small tutorials for people to go through to learn how to use the Python API for QGIS. And I call it PyQGIS 101. It's on my blog. I also use it for teaching because I teach at university level and not all of the students have a computer science background. To be honest, almost no one has a computer science background. And I was really amazed by how many people are now doing the Python exercises and are doing them really well compared to before, when I just told them they were supposed to take a Python class first before they take my class, because I would assume that they know the basics of Python. And now I don't anymore. And the PyQGIS 101 is kind of the replacement. It's an introduction into both Python and programming for QGIS.
Yeah, thanks for that. I will definitely link those in the show notes so people can go back and find that resource there. I've had a quick look through it myself, and it looks amazing. I remember for myself when I was learning, it was really good idea to have a problem that I needed to solve. It was so much more motivating for me personally, and I think you mentioned it before as well. This sort of model builder idea that we see in QGIS, we've seen it in Esri and ArcGIS as well. So that graphical model builder, I think that's a great place to start for some people at least, just to get the idea of what a script looks like. How can I execute it outside of the program, for example? How can I manipulate some of these parameters? And I think that might be a really good starting place for some people at least.
Yeah, absolutely, because it takes a lot of the complexity out. You basically have to take care of feeding some data to the model components and then chaining them together. So that's a good introduction to writing scripts. Of course, if you are not chained to the script thinking of the model builder, you can do many more flexible things. And it's important to show people that there is much more flexibility in programming than you can get out of a model builder, because that also keeps them motivated to learn more. And they understand why the model builder scripts are really just the first step. But as you said, if you have a problem that cannot be solved easily with Model Builder, that is usually great motivation to then dive deeper into Python and what it means to program something from scratch.
So I really feel like you've given us an excellent overview here, all the things that Python can do, the advantages of learning it, and how we might get started. You've given us some really great resources. Thank you so much for that. So let's move on and talk about something that you've become quite well known for, at least in my mind, and that's Geopandas. Can you tell me what Geopandas is?
Sure, so Geopandas is something rather new, to be honest. Maybe let's start from the beginning. It's called Geopandas because it's a spatial extension for a library called Pandas. And Pandas has been around since around 2008. It's an open source library that is specifically designed to make data analysis easy. And they have something that's similar to our GIS layers, and they call it data frames, which is basically a table of data, or it can be a time series of data if it's indexed by the timestamp. And what it does is very similar to a database. It makes it easy to put indexes on the data, to filter the data, but it also has really convenient functions to read files, to write files, to deal with missing numbers. For example, if you have some null values in your data set where nothing, no measurements have been recorded in a time series, for example, you can tell it to fill those empty rows with something. That could be the last observed value or the interpolation between the previously observed value and the following value that happens to be in the data set. And all those convenience functions, they really make a great package for anyone who has to work with real world data. You can also do pivot the tables and reshape tables, groups and merges. So there's a lot of that you can then do in Python that usually require the database. And that means that you can write standalone scripts and you don't have to have this dependency on a database to make your analysis in a straightforward fashion. And finally, of course, there's a lot of plotting capabilities as well. So this pandas library was around for a while already, and Geopandas really only came on the table around 2013. I think I'm not a pandas historian, but that's approximately the numbers that I'm aware of. And what they did is they made it possible to store geometries in the data frames. So again, it's this like the parallel to Postgres and PostGIS, where PostGIS gave you the way to store geometries in the database table. And Geopandas builds on a lot of libraries that were there already before. So people might be aware of Shapely library or Fiona for reading and writing different spatial file formats. And of course, there's also a lot of geospatial plotting functionalities with libraries like matplotlib or more modern interactive ones that are based on Folium. Folium provides Python support for leaflet, so that creates a leaflet map. Or there is HVplot, which I have recently started to use for interactive plotting because it really has some nice functionality and is good and has good performance. That's basically the background of Geopandas. And why should you use it? I think because it's much easier to write something that is really standalone and can be used outside of the usual desktop GIS environment. And it's much more familiar way of programming for non-GIS people who might already be familiar with pandas. So if you work in a team with people from different backgrounds and you're the spatial data person, you might find it much more easier to convince them to work together with you on the same code base if you can adapt a bit to their way of thinking by going with Geopandas instead of insisting to do something with a desktop GIS API like ArcPy or PyQGIS.
Okay, so it sounds like there is a ton of functionality in GeoPandas already. And you mentioned a lot of the libraries that were sort of glued together under this umbrella, I guess, that we could call GeoPandas. Could you talk us through that? Because I think this is a really important part of Python, is to understand that it's so flexible, the language itself. So my understanding of Python is that you just take in the libraries that you're interested in and sort of mix them together in different ways. Can you can you talk a little bit more about that? Is that a good way of understanding how this works? Is that a good way of understanding how flexible these different libraries are?
I think that's a good way of thinking about it. So the key to understand here is that programmers are good programmers. They don't want to reinvent the wheel every time. So when there's a good library out there that does something really, really well, you usually want to reuse that and build upon that and build a component that just solves that extra bit that might not be implemented already. If we already have libraries that can read all the geospatial file formats like Fiona already does or has been doing for a lot of years, then it's obvious that we might want to use that and integrate that. And in Python, that's really straightforward. The only challenge that remains, and if people start using Python to write their own scripts, they will notice that rather quickly, is that, of course, due to this modular nature, we have to ensure that the modules that we assemble together are compatible. So everything evolves, versions keep changing. And one of the challenges working with Python certainly is to ensure that all the components are compatible when you want to use them together. But there are solutions for that, and I think we are getting better. It used to be real hassle in the past. Nowadays, there are ways to restore, as it's called, a certain Python environment, to restore that to working configuration more easily.
So let's talk about that in just a little bit more depth here, because I think that this is definitely a problem that I've run into installing different libraries, is that they don't work. Oh, I need this dependency somewhere in the background. I need to find that DLL from somewhere and put it in. Oh, I need a system path, whatever, that needs to be updated. So it's obviously a very, very flexible language. We can glue together all these different libraries that exist already, packages that exist already, and build on top of them. But with that flexibility comes a lot of complexity, at least in my mind. Can you talk us through how we can avoid some of that? Is there anything out there that lets us install environments so that they're ready to go with all these geospatial capabilities?
Yeah, in general, I would recommend to always follow the installation instruction of the respective library that you want to use, because they know best what's the currently working configuration. In the case of Geopandas, the currently recommended way is certainly to use the Conda installation. So by default, all Python installations come with something called pip for package installing. But pip, unfortunately, does not work with some of the Geopandas dependencies. They cannot be pip installed well, particularly on Windows. So to have something that works on all major operating systems, Conda is recommended by Geopandas. And basically what you need to do is you can run it from the command line if you prefer that, or there's a desktop application called Anaconda, which gives you a graphical user interface which lists all the available packages, and you can click on the ones that you want. And it is able to resolve which dependencies it needs to install and which versions of those dependencies to hopefully ensure that the environment then is working.
Okay, so let's say I'm installing this on a desktop and I want a graphical way of doing it. I download Anaconda, I choose the packages that I'm interested in. It'll automatically find out what dependencies I need and download and install them on my machine. So now I'm ready to go. I have my environment. What about how do I actually code? Are there any editors out there that you can recommend that work really well with Python?
You can even install those from within Anaconda as well. So Anaconda has multiple different IDEs, so editors that you can use with Python. And by default, it suggests you to install either PyCharm or Spider. Both of them are fine. I think Spider is completely open source, and PyCharm has a community edition that is also free to use. And for people who already come with programming background and who are maybe Java developers, they might be familiar with IntelliJ, which is a very popular Java editor, and PyCharm has the exactly same layout, so it would be very easy for them to get into that editor as well. It's also my personal favorite, so I usually go with PyCharm for writing Python code because it has really convenient functions for refactoring and making easy to read code that is hopefully self-explanatory.
Okay, so I think we've almost been through from the bottom of the list, I should say, to the bottom. So we understand the advantages of Python, how it sort of works, in terms of we have all this functionality, and if we're talking about Geopandas, for example, we understand there's a whole bunch of different packages that we can link together. You walked us through what we can use and how we can install it, and then finally we got down to these editors. So these desktop applications that we can use to edit our code with. I'd like to sort of move on now and just ask a few sort of questions that will hopefully give the listeners an idea of what's happening out there in the future of Python. So let's look at that. What does the future of Python look like? Can you see any trends emerging in terms of geospatial?
I think one of the really huge things is that Python is really well adopted in the industry out there in data science in general. And as I mentioned before, with things like libraries like Geopandas, we have this opportunity to fill the gap between non-spatial data scientists and the people who come with a geospatial background, and to work together and to have a much more close integration of spatial analysis capabilities and the regular machine learning and deep learning AI functionality that most data scientists work with. So in the industry, I think this is the biggest role that Python plays to integrate between different backgrounds. On the research side of things, which is my background currently because I work in research, I see huge potential to improve the reproducibility of research, particularly with technologies like notebooks, which can be used to really record an analysis step by step and to show the intermediate results and all the plots that you might generate for a report or for a scientific paper in the context of that code. So it's not like in the past you wrote a script and when you run the script, it would dump all the images into a directory, and then you would have to look on the one side at the code and on the other side find that figure in your output directory and see, okay, does this make sense? Do I understand what's going on here? No, instead, in the notebooks, you just execute one part of the notebook, which is called a cell, and it will immediately plot the output under that cell. So the output can be, of course, just text, but it can be graphs. It can be interactive graphs like a leaflet map or some other Bokeh, for example, interactive plot. And this way, it's much easier to debug if there are issues and to just understand the whole data analysis flow. And if you ever had the honor to inherit someone else's data processing workflow, you will really start to appreciate this step-by-step debugging and learning about what's really going on in a piece of data munching code.
I really like the way you said honor of inheriting somebody else's work. And
It's questionable.
Yeah, and I think if anyone has had, the honor of doing that, they will completely understand what you're talking about. I just want to say for the listeners here, I think that what you're talking about when you refer to notebooks is Jupyter notebooks, and this is I think is a really exciting tool that's out there, really exciting technology, and I'll plan to do an episode on this later on. So for the moment, we'll just leave it at that. But if you are interested in that, go out and search for Jupyter notebooks. It's a really interesting technology that's, I don't know if it's emerging, it's been around for a while, but it's super exciting, I think, the potential of it.
Yeah, there's a couple of different notebook technologies, but in Python, certainly Jupyter is the most prevalent one.
So I feel from what you said before, like there's a lot of interesting things happening around Python. It's a hell of a lot of attention. It's that glue that binds a whole bunch of different geospatial applications together, and there's a lot of flexibility and potential in it. But we've also seen this with other languages. Do you think this is going away anytime soon? So languages come and go. Something better shows up and move and takes over. Do you think is the popularity of Python, is that peaked, or are we still on the way up?
According to the recent trends that I'm aware of, it's still very well on the rise. And I don't really see any contenders on the horizon. And that could probably be because there is something for everyone. So there is the argument that it's really easy to get into for the beginners, but there's also ways to make it really efficient if you need to by writing some parts of it in Python, which then under the hood uses C and is much more performant. So there's really not many reasons why you would want to abandon it once you're into it. Of course, for people who come from the Java world of things with the Java virtual machine, and for people who work in big data settings where so Hadoop and Spark, they tend to use Scala and Java to get their work done, and that's perfectly fine. But even there, people with data science backgrounds have started to build bridges to Python. So there is PySpark that allows you to interface Python again with those Java virtual machine worlds in the big data settings. So I think it will be around for a very long time, and I certainly would encourage people to learn Python. It's not going away anytime soon.
Okay, so it's not going away anytime soon, but when is Python not the right answer, do you think?
Obviously, if you have to build for an existing system, and that is in a Java-based language, then I would not recommend introducing this interface without having a really, really good reason to do so. So if your company is built up on Java applications, you might very well want to stick to the Java world of things. And there's a ton of libraries there as well to do geospatial, like GeoTools, for example. So I wouldn't start to mix and match languages if there is not an extremely good reason to do so. But if you can start from scratch and if your work is related to data science, then I don't see any reason why you wouldn't use Python.
One final question for you, Anita, before I let you go, and that is, if you had to learn another language today, what would you choose? And this is, of course, from a geospatial perspective.
That's an excellent question. For my current work, I think it would be most useful to be a bit better at programming in Scala, because we've recently started to deal with a lot of really large data sets which have to be manipulated, or if you want to manipulate them efficiently, you have to do it in a distributed computing environment. And while we have set up a cluster for doing just that, I think I could be way more efficient in using it if my Scala magic was a bit more advanced already. So I think knowing Java and Scala would be really helpful. And I use those two here interchangeably because they are very related and can be used in combination with each other's. So either one of those would help me to solve those challenges better in the future.
Anita, I really want to thank you for your time. It's been a pleasure talking to you. I'm a big admirer of your work. You've helped me out in the past. You don't know this, but you've helped me out on GIS Stack Exchange many times by answering questions. So thank you so much for that. I will definitely include those resources that you mentioned during the interview in the show notes so people can click through to your website and learn more about you. But is there anywhere else where you would like the listeners to go if they want to reach out to you or learn more about your work or about Python?
Sure. So the best place to learn more about my work is certainly on my blog. You will find there a lot of recent developments in Python, in QGIS. In Python specifically, I've started working on my own library that I call Moving Pandas, which is an extension of Geopandas. So you see, it's the extension of the extension. That's just how things work. And it's really, really focused on doing stuff with movement data. So if you have vehicles that move, people that move, or goods that you want to track and you want to analyze this kind of data, that's the library to go to, or I hope it will be the library to go to in the future. And I'm always very happy to hear from people who use it, try to use it, and learn about their experiences. So reach out on my blog or on Twitter. Those are the two main avenues, I think, to get in touch.
Thanks again for your time. I really appreciate it.
Thank you.
So I really hope you enjoyed that conversation with Anita. She has some really incredible insights and a massive depth of knowledge in terms of Python, geospatial, and of course open source. So she's a guest that I would really like to have back on the show. But I'd like to hear from you. Did you enjoy the conversation? What would you like to hear more of? And again, you can reach out to me through our email if you would like. Go to mapscaping.com/podcast. You can subscribe there and use that as a way of getting in touch with me, or feel free to reach out to me on social media or catch me on LinkedIn. Just search for the Mapscaping podcast host. You'll find me, and I would love to hear from you. It would really help me shape the direction of this podcast. And that's it for another episode of the Mapscaping podcast. My name is Daniel, and it's been an absolute pleasure being your host again this week. I'll be back again next week with another great episode for you. I hope you can tune in then. We'll talk then. Bye.